Okay, so the first one what we're gonna do is chapter 8, algebraic thinking. When we're thinking about algebraic thinking, what comes to your mind?
Algebra.
Algebra, like what? What's algebra to you? Is it just a hard subject or your favorite subject or what comes in your mind?
Like A, B, C, like letters and equations and stuff.
Ah, so there are variables in it, right? We use a lot of variables instead of your numbers, right? It's really good. And we use equations. We put some expressions there. Why? Why do we do that? Why do we do that? Why do we use letters instead of numbers? Have you ever thought about that? Why letters? Why can't we use this blank, like square and circle? Why? Anybody? Is that a stupid question? That's why you're not answering me. Why do we do that? When do you use that variables?
You're trying to find something.
Right, when we don't know something, but we want to try that, right? We want to try to find that out, right? So we use alphabet a lot of times. Well, we can use blanks, it's okay. But sometimes you can confuse what the blanks are. Sometimes you can make circles, sometimes you can make a square. If you're consistent with it, that's fine. We can start from that when you have little kids, because they don't know alphabet, or maybe alphabets can confuse them. Then you can just consistently say that, oh, this blank is something that we're gonna find it out. Later on, you can say that instead of blank, we can use the alphabet. So let's say we don't know this, but we want to find that out. Let's say that that's an A, and let's find what A is. Okay, that is a variable. So variable, when you're thinking of variable, vary, what does vary mean? It means it changes, right? So variable, the numbers can change. That's why we don't use a fixed number. Because if you use a certain number, it's fixed. But what we're gonna find here is, as a variable, it changes. Okay? And by the variables, you can have the different results too. Okay? So I'm gonna give you this problem. This is from a Facebook. I didn't actually find it. The textbook actually found this for me. Okay, so let me ask you to find the answer for this question. I think it's fine. It is fine. Okay, so you can see that together the cat and bunny weigh 10 kilograms. Dog and the bunny together 20 kilograms. Dog and the cat together 24 kilograms. We want to find out how about all of these together, all three animals together, how much do they weigh? And even further, I wanted to find how about individual animals weight. Can you find it too? You don't have to use variable if you don't want to. If you want to use a variable, you can do that. For instance, maybe you can say that the dog's weight, let me put dog's weight as D. Let C be cat's weight. Let R be the rabbit's weight. Something like that. You can do that. If you don't want it, you don't have to. I'm gonna give you guys about 2 minutes. Now we need to ponder how you can find the answer for the total weight of these three animals. And if you're done, I'm going to go further to find individual animals weight. When you find the answer, please show me your thumbs up. You don't have to raise your hand really big, but I want to find out whether you are done or not. How many of you solved this problem? Nice. Anybody wants to share their strategy? Elisa? How did you solve?
I just kind of like random numbers.
Oh, you did. I like that
Yeah.
idea too. So one strategy, you can just try and error, right? Try and error. You can put random numbers. If you're lucky, you can find the right answer. But you can be very reasonable when you're plugging the numbers too. I don't think Elisa put any number bigger than 10 there. No, because the sum has to be 10, right? So you can have some reasonable numbers. What number did you try?
Well, I started with 2 and 8.
2 and 8. So you can see some ordered pair there. So C and R, I'm gonna just put the ordered pair, and you started with what?
2 and 8.
2 and 8. Okay. And did it work? It didn't work. It didn't work. Why? Because when she put 2 and 8 there, it worked for the first sentence. But here, R is 8, then D has to be what? D has to be 12. If D is 12 and C is 2, it's not 24. So did you increase the C's number?
Yeah.
So what did you do next? 3?
Well, I figured out R has to be lower than C.
Oh, R has to be lower than C. How did you find that out?
When it comes to the rabbit and the dog.
Rabbit and the dog.
Yeah.
Okay.
Oh.
Just tell us what you did. Your
Okay.
strategy. Yeah. After 2 and 8, what did you do?
I did 3 and 7, but I
3
made
and
the
7.
rabbit
So,
3 and the cat 7.
oh, hold on. Cat 7?
Yeah.
So this didn't work, so you did it 7 and 3.
Yeah.
Okay. And what happened?
That one worked.
That won't work? Oh. So if you put 7 and 3 there instead, let me change it. Okay. So C is 7 and R is 3, so it's working. So R is 3 should be C? 17 plus 1 makes 24. 7? So it is our 7, right? So yeah, it worked out. It took some time, right? But she found it. So trial and error works, but it takes some time, sometimes enormous of time. And it often makes your students give up, right? So I don't think that's the best way, right? Okay. So let's think about a little bit more efficient way. Anybody else? What was your guys' approach? Was it a little bit different from Elisa's? Okay.
Well, I started something that I remember doing in high school, but I don't remember how to finish it, so I can show you.
How did you start?
I did cat plus dog plus 2 bunnies is 30.
Cat plus
Dog,
dog plus
2 bunnies.
2 bunnies. Why 2 bunnies?
Because the cat and bunny is 10 and the dog and bunny is 20. So I added the 10 and 20, make 2 bunnies.
Ah, okay. So adding these two together. So you got 2R. Okay.
And then I did that for the for the dog and for the cat too, but I don't remember what to do after.
Right. So you still have 3 letters, right? So if you guys remember, when you have 2 variables, you need to have 2 sentences. When you have 3 variables, you need to have at least 3 sentences. Luckily, we have 3 sentences and we have 3 variables, right? So we're gonna use this more efficiently. And take a look. How many C's do you have? Here. 2. How many R's do you have? 2. How many D's do you have? Oh, all 2's. So if you add them all together, what happens? I have 2 C's and 2 R's and 2 D's. So can I add them all together? The left hand side I add all together and I got 2C plus 2R plus 2D. How about right hand side? 10, 20, and 24. What is it? 54? Okay. And everything is added by 2's here, right? So you can factor that out. Or you can just say that, oh, that's the same as 2 times C plus R plus D. You agree? That's 54. If double of C plus R plus D, their total weight, if double of the total weight is 54, what is their total weight then? It's half of that, right? What's half of that? 27. So we got the answer for the total weight here, using the variable.
I was so close.
You were.
That's
Yeah.
so dumb.
And also, and also my last question that I asked you, right? From here, can you find C, so cat's weight and dog's weight and rabbit's weight? Using this and using all the information you have. Jalen, how can we find these individual weight? Using the information you have and the total weight we found. Compare them. Comparing no different color. This and that. What can we find using these two? What can we
Then
find?
you could like do the subtraction and cancel out the C and the R, then D is whatever's left.
There we go. There we go. We know cat and rabbit's weight together is 10. So cat and rabbit together is 10. So 10 plus dog's weight is 27. Then what's the dog's weight? 17. Using this and the second sentence here, D and R, what can we find? We can find the cat's weight. What is the cat's weight? 7. And using this, what can we find? The rabbit, yeah, the rabbit's weight. What is it? 3. There we go. Okay. So variables are very, very, very useful when you're using them. Okay. Okay. So that's what the variables are for. And here's another example that we can do. In each of the following descriptions, translate the given information into symbolic expression involving variables. So in the previous ones, we were just given the pictures, right, of the weight. But we changed that to variable and the symbolic form with the additions and equal sign. We put the equations there, right? So that's what we're gonna do here. Let's think about translating words into numbers and symbols mathematically. So the cost of renting a car for any number of days at $40 per day. What do you think? If you have to pay $40 a day per day, how much do you have to pay? After 1 day, you just pay 40. After 2 days, how much do you pay? After renting that for 2 days, how much do you pay? 80. How did you find it? 40 times 2, right? After 3 days, 40 times 3, and so on and so on. But we don't have any fixed number. It says any number of days. So you need to define what any number of days. If you want to use n, you can say n, let n be any number of days. Or you can put d and say d is equal to any number of days. You need to define the variable so we get to know what the variable means. Okay? So if we are doing the n as the number of days, the cost of renting a car should be 40 times n. Right? Okay. How about this? The distance a car traveled at a constant speed of 65 miles per hour for any number of hours. So let's put some numbers for us to understand that better. If we travel for 1 hour with 60 miles per hour, how many miles can we go? It says 65 miles per hour. 60 miles per 1 hour. So for 1 hour, we can go 65 miles. After 2 hours, we can go double of that, right? Times 2. After 3 miles, times 3. So we can get to know the distance should be 65 times how many hours, right? You can say that, oh, I can put any number of hours. Let n or h is equal to number of hours. And the distance is equal to 65 times h, right? How about the third one? This is a little bit complicated. Maybe a lot. I don't know. Can you try this? So we use variables in problem solving a lot of times. Okay? One weekend, a store sold twice as many 8 GB flash drive as 64 GB flash drives, and 25 fewer 256 GB drives than 8 GB drives. Is it really confusing? Yeah. So when you're making word problems, you need to be careful about the wording. You shouldn't confuse your students. Okay? I don't like this specific problem so much because we are already dealing with the numbers like twice as many and 25 fewer. And we have 8 GB, 64 GB, 256 GB, another numbers there. So those, all the numbers may confuse your students. If then, maybe you can just change that, let 8 GB as A, 64 GB as D, something like that, you can change that numbers into variable, okay? So, I will ask you guys to spend about a minute or two to solve this problem. Let's see. You may face this kind of problem when you're working with your students in the public school, so please try to solve it and persevere in solving them. it says if the store sold D many 64 gigabytes, right? So you can let D be 64 gigabyte drive sold. Okay, it already tells you how many 64 gigabyte drives D many. Okay, so use that variable. When you're solving a problem like this, word problems, you may want to see what's important there. So I will underline or highlight what's important information there is. If there's nothing that is important, I will cross it out. What I did is on my whiteboard here, I made this little bit shorter. So what I put here is I just copied it down, but a little bit simpler. I put twice as many 8 gigabytes as 64 gigabytes. That's important information that we're gonna use. And another one is 25 fewer 256 gigabyte drive than 8 gigabyte. The third one is D is equal to number of 64 gigabyte drives sold. Right? So these are the important sentences that we're gonna use. I still have the sentences. Can we change this to the numbers and symbols? Let's look at the first one. Twice as many gigabyte as 64 gigabyte. How can we change this to number and symbols? Which one is more? 8 gigabyte? 8? So 8 gigabyte is more. By how much? Twice as much, right? So 2 times of 64 gigabyte. Does it make sense? Okay. If you don't like 8 gigabyte and 64 gigabyte, you can change the variables too. Okay. Like we put D as 64 gigabyte. So instead of 64 gigabyte, can I put that as D? Right. So 8 gigabyte is 2 times D. Good. Similarly, we can do that here too. It says 25 fewer 256 gigabyte than 8 gigabyte. And 8 gigabyte is what? 2D. So from 2D, if you wanna make it fewer, what do? You're gonna subtract 25. Very good. So that is what? 256 gigabyte. Make sense? So we have 8 gigabyte as 2D many sold and 64 gigabyte we sold D many. You already said that there, right? And 256 gigabyte we have 2D minus 25. Make sense? Okay. Good. There's one more. How about the last one? French fries. Oh, that makes me hungry. French fries have about 3 calories a piece. A hamburger has about 250 calories. Would you count French fries saying, oh, this is 3 calories? I wouldn't do that, but anyways. Yeah. Matteo is on a diet of 1200 calories per day. If he ate F many French fries and 1 hamburger, how many more calories can he consume that day? How is it going? Any idea? I think Anna can answer this. she's on the spot.
It would just be 3F plus 250.
What do you think, guys? That's how much he or he's gonna consume, right? But he wants to have 1,200 calories a day.
And we want to subtract that from 1200, like 3F.
Or the other way around.
Yeah.
The other way around, because 1,200 calories is what he wants to consume, right? So from there you can take away, well, 1 fry, 2 fries, 3 fries, calories, and hamburger, right? So from 1,200 calories you can take away 450 and take away 3 times number of fries. So if I write it down here, it's gonna look like this. 1,200 calories is the total calorie he wants to consume. If he eat 1 hamburger, how much calorie? 250. So after that, he can eat some more fries, right? But per fry, it has 3 calories. So 3 times as many calories he can consume, right? Okay. Okay, here's another example. This is a really cool one. I love this one. Okay, I can ask you this question. Take any number. You pick any number. This is like magic. It's a mathematician work. So pick any number. Have that in your mind. You got it? Look at anybody. Okay. Do you have your number in your mind? Okay. Add that number by 15. So add 15 to your number. Add 15 to your number. Got it? Now multiply that number, the new number, by 4. You can use your pencil and paper. Multiply your new number by 4. Then subtract 8 from that. Subtract 8 from that number. And divide that difference, the new number that you got after subtracting, divide that by 4. Got it? Then you're going to subtract 12 from their quotient. Subtract 12 from the quotient you have. You got it? Okay. And this is magic. Let me ask Emily. Emily, what's your number? Oh, I cannot hear you. Is it me? Emily? Well, we cannot hear you. I don't know why, but maybe you can. Where's the chat? Can you leave that on the chat? Where is the chat?
It's over here.
Where?
Up on that.
Thank you. Okay, just put your number there, Emily. Eight. Okay, that's her result. Let me guess what her number is. Was your original number 7? Yes. Yay! I got it. How about Madison's Sandstrom? What's your result?
4.
What is it? 24? 4?
It was 4.
Just 4? And your original number was 3? Ooh, how did I know? Hannah, what's your number? 3. Your original number was 2, right? I can guess it. How? What is it?
It's just one less than the original.
Oh, it is. It is. I always say the one last number, right? How did it work? Let's figure that out. Thank you so much, guys. Okay, hold on. So, I need to have another board. How can I share that? Okay, I want everybody to write this down on the notebook. So take any real number. Instead of that any actual number, can we use a variable? Like n or a or whatever that number is. So take any real number and use a variable. Just like n. Add that by 15. Hold on. Add that by 15. We're gonna go back and forth. I think that's what we need to do. Oh, actually I can see from here. That's nice. Okay, so let's go here. Nice. Take any real number. What variable did you use? 2? I mean, any real number. Instead of actual number, we're gonna use a variable. Something like x. Okay, so x is our real number. So we gotta take any real number, the first step. And next, add 15 to it. So how do I write it? 15 plus x or x plus 15? Either one works. So 15, yeah, add 15 to that. And then third step, multiply that sum. Sum is the answer of the addition, right? You wanna multiply this by 4. How do I write it? Thank you so much saying that the parenthesis there. Why do we need a parenthesis there? Exactly. If I don't put parentheses here, look at this big difference here. 4 times, if I just multiply 4 and put times x plus 15, what happened? What happened here?
4x plus 15.
Yeah, I just multiply 4 to the x, not to the 15. So we need to multiply 4 to the sum, the whole thing. So make sure you put the parentheses. It's very, very important. Okay? And then what? Subtract 8 from that. This is the whole thing. Which one do I have to write first? 8 or this? The 3. The 3 first, right? Because we are taking 8 from that. We're going to subtract 8. Okay? So we need to put 4 times x plus 15 in the parentheses minus 8. Then what does it say? Divide the difference by 8. The difference is an answer for a subtraction, right? So we have subtracted here. Look at the big picture. This whole thing is subtraction. So the difference should be the answer for this subtraction. You're gonna put the whole thing there. And say, then you're gonna divide this whole thing by 4. Right? And then what? Subtract 12 from the quotient. So if you divide this by 4, that you can have the quotient, and then you're gonna subtract 12 from this whole thing. This is what we have. Now, oops. Why did this happen? Where's the x? Okay, it's coming. Go back here. All right. So this is what we have. But how can we go to that guess I had? I always said one last number from the result. But this looks really, really complicated, right? So can we simplify this? Can you help me? How can we simplify this? 4 and 4? Because we can break this fraction into 2 parts. 4 times x plus 15 over 4 minus 8 over 4 and minus 12. Why can I change this whole thing as these two fraction parts? Because I have the same denominator there, right? So this is the same as this minus that. Now we can see that both have 4 there, so we can divide numerator and denominator by 4. We have 1 here, 1 here. And same thing here, divide 8 by 4, you get 2. Divide 4 by 4, you get 1. So this whole thing is what? 1 over 1 is 1. 1 times x plus 15 is x plus 15. And this one? Minus 2. And we still have minus 12. And what is this? X plus 15 minus 2 minus 12. Minus 14, isn't it? That's the same as x plus 15 minus 14, 1. So the sum, the total, the result number is always 1 more than the original number, right? That's how I could figure out what your real number is. Make sense? Okay. So you can play things like this with your students too. That's gonna be fun. Okay, and what happened here? Okay, so that's what we had. And we're going to talk about arithmetic sequences and geometric sequences. Arithmetic sequence, arithmetic. In arithmetics, it's much more simpler, so we're going to keep adding the same number. In geometric sequence, we're going to keep multiplying the same number with a pattern. So when you're looking at this number pattern, 5, 9, 13, 17, 21, 25, dot, 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 you can see a certain pattern there. What do you see? What's the pattern here? What's the rule? You keep adding 4 to the previous term, right? So 5 plus 4 is 9, 9 plus 4 is 13, 13 plus 4 is 17, plus 4 is 21, plus 4 is 25, etc., etc., etc. Right? So if you think back to Math 137, a long time ago, you could remember inductive reasoning and deductive reasoning. And this is what kind of reasoning is that? Inductive or deductive? We are using specific case here. So it's what? It's inductive, right? Because we don't have like all of the numbers here, we cannot make a certain conclusion here. But based on our observation, based on our pattern here that we observe, we can say that, oh, we may keep adding 4 to the previous term. So that's inductive reasoning. Okay, it's not generalized yet. So we're gonna find a general form here to find the 100th term. Instead, you keep adding 4 until you reach to the 100th term. Do you wanna do that? No, takes too much time, right? So instead, we're gonna find a general term here. So let's take a look at that. Do you have any idea? Please share that with us. Does anybody have any idea to find the 100th term easily? You're just too shy, I know. Right? So this is the first term, right? That's the first term. And we added 4 to that. The second term, and added 4 to the third term, and so on and so on. So I can do the first term is equal to 5. A sub 1 is 5. And a sub 2 is what? 5 plus 4. Right? I added 4 to that. So that means 5 is a sub 1. The first term plus 4. Can I write it this way? In the third term, I added, let's put a2. Second term plus 4. Right? But what is the second term? Second term is a sub of 1 plus 4, isn't it? So can I substitute a sub 2 as a sub 1 plus 4? Can I do that? So I'm adding 4 to that. Are you following? And a sub 4, the fourth term is what? Third term plus 4, isn't it? So my third term is this whole thing. A sub 1 plus 4 plus 4. That's the third term, and I'm going to add 4 more to that. If we keep doing that, we can find the pattern here. So I have a sub 1 and a sub 1 plus 4, a sub 1 plus 4 plus 4, but I can change this to what? A sub 1 plus 2 times 4. Can I? Yes, I can, right? Because I have 4 plus 4, repeated addition, we can do the multiplication, so 2 times 4. And this one, the third term, fourth term is same as a sub 1 plus, how many 4s are there? 3 many, right? So 3 times 4. Now can you compare the number of terms and the changing numbers here? Numbers changing here is 1, isn't it? I didn't write that. But 4 is the same as 1 times 4, isn't it? How about here? 2 became 3, and now what has been changed? I see a sub 1 is still the same. 4 is still the same. But what has changed? Yeah, the number right in front of 4. This has changed, right? So can you compare the term number change with these number change? You see that, right? Then can you guess what could be a sub 100?
Maybe A1 plus 100.
A sub 1 plus 100 minus 1, right? Which is 99 times 4. Because this is always 1 less than the number of terms, isn't it? Very nice. So we can find the 100th term. Can we generalize this then? A sub n for any term. What is it?
N minus 1 times 4.
We need to add the first one, right? The first term, and then n minus 1 times 4. There we go. So we can find not only the 100th term, we can find 999th term, and so on and so on and so on. So for any geometric series, you can have this conclusion. So for any arithmetic sequence, you can conclude a sub n in arithmetic. You can add the first term, and then you can subtract 1 from the term number and multiply that by the change. In the previous one, we keep adding 4. But that 4 can be changed as the addition number, d. So we can do that sequence as a sub 1, a sub 1 plus b, a sub 1 plus d plus b, a sub 1 plus d plus d plus d. These series. That sequence is called arithmetic sequence, and you can generalize to find any term, Make sense? Okay. We're gonna stop here today, and we're gonna go a little bit more for this sequence, especially the geometric sequence. Multiply same number, the previous term. Okay. Then I think we can move on to the second section. I think the homework for this one is already open. That is I said that is due Friday, but I'm gonna move that to Monday. Okay, because we didn't finish that. Okay, we're already behind. All right, great job everyone. And you can go ahead and start your homework, okay? If you have any questions, please do not hesitate to